Alright, my car just fired up, no problem. But we have a battery light on. Car did start and run. It hasn't ran in a minute, but we got our battery light on. Alright, hello and welcome. My name is Clayton. Today we are going to do an alternator on the Lexus LS400. And we're going to talk about some of the other things to look out for and know about the alternator on these cars. So how do we know we have a bad alternator? What are some of the things that indicate this? Chances are you're looking at doing an alternator because your car won't start. Perhaps you just drove somewhere and now your car won't start even though it started okay. This is because as you start your car and you drive, your battery discharges and the alternator is supposed to be keeping that battery alive, and it didn't. Another thing that might happen is the battery light comes on in your dash while you're driving. That's what happened to me here. The battery's job is to store energy that allows your car to start when you go and crank the key. The alternator is driven by the engine, which supplies the electricity that keeps it alive while the car is running and also recharges the battery. It does this by, well, using the alternator as a generator powered by the mechanical power of your engine to create more voltage than necessary that goes into the battery. In the past, alternators would have external voltage regulators and some other things that would kind of complicate the entire system. Generally speaking, there's a lot of internal regulators in alternators these days, and beside the actual fuses, there isn't a whole lot involved in your charging system. On the Lexus LS400, people have discovered that the LS430 alternator can be used as an upgrade. The LS430 alternator offers an additional 30 amps, and I believe the holes to mount it to the engine are the same, however you will need a new pigtail. People also suggest doing the Big 3 upgrade, which is a common upgrade in the automotive world for people who run aftermarket sound systems. Upgrading the Big 3 consists of upgrading the power wire that goes from the battery to the alternator, the negative wire terminal from the battery to the chassis, and the ground from the engine block to the chassis. The only reason that I didn't do this upgrade was just because I was a little nervous to do the Big 3 upgrade as well as figure out how to wire the pigtail and everything, and really my car was just acting up and I just wanted to replace the alternator and get my car running and use it as a daily again. However, I did spend some time researching this, and basically what I found is that there are a lot of people who have tested this, and an oversized alternator does in fact give you quite a few benefits. The thing that's hard to wrap my head around is how exactly does an electrical system with a higher load physically load the alternator more? I believe one of the ways is because this I don't know if it's technically an armature on an alternator, but because this is constantly spinning, it's essentially a magnet passing a magnet, and I believe if it has a higher load, the magnetic force that's adding resistance to it spinning might be more. And again, that's just a complete guess. I'm not sure that's exactly how it actually works. Oversizing an alternator actually does have benefits. It does help the alternator overall be loaded less. Anecdotally, there's a lot of people in the LS400 community who have upgraded to the LS430 alternator and have concluded that their lights are brighter, it seems to run better, they think their gas mileage is better, all these kind of things. Again, a lot of people also recommend doing the Big 3 at the same time. This will guarantee that you have to use a different connector for the LS430, and you will have to figure out the wiring. However, it should bolt up and share the same mounting holes and otherwise generally be the same. That's a really common upgrade that a lot of people do, and I'm probably going to recommend people do it. Again, the main reason I didn't do it was just because it was, well, cheaper, faster, and easier not to for me, and I really just wanted my car back. I'm not going to go into the full process of properly diagnosing this. However, there are a few things that you can use to pretty much confirm the problem. First of all, what I like to do is measure the open circuit voltage of the battery. So here we're reading at 12.45, which is actually a little low, believe it or not. A battery is fully charged at 12.66, and 12.45 is actually technically a little discharged, even though we're over 12 volts there. However, that is still plenty enough to start the car, and so we're going to prove that right now. Alright, now that the car is running, we will do the same thing. And as you can see, it is now down to 1175. When a car is running and healthy, we should see the voltage anywhere from 13.5 all the way up to like 15.5 while the car is running. There are some cars that can switch off the alternator, which might mess with this reading. However, on older cars, typically that's not the case. Almost any time I've diagnosed an alternator on my personal cars, it's been by just looking at the battery voltage while the car is running. And if we're getting like 11 volts or 12 volts while the car is running, that means the alternator, to me, is not doing anything. But there's a lot of reasons that an alternator might not be charging. So here I have a full diagnostic checklist that is the proper way to go through and diagnose this, and I'll read some of it and kind of go through the process. But first things first, check battery terminals, fusible links, and fuses. Anytime I pop the hood and I'm looking at a battery, I want to grab both ends of the terminals and make sure that these are not loose. I want to make sure that the battery is nice and tight. I want to make sure there's nothing obvious that's going wrong, like frayed wires, open wires, anywhere where it looks like open wires are making contact, etc. Sometimes a visual inspection goes a long way. However, this battery I bought maybe a couple months ago. My terminals are looking good, nice and clean and tight. So now I'm going to open the fuse box. And here we go. So I was able to find a fuse diagram in my owner's manual. So if you still have your owner's manual, this can be a helpful tool. Driver's kick panel, engine compartment. I believe that's where I'm looking. So what I'm looking for, according to this, I'm looking for fusible link Alt 120A, AM 140A. The fuses I'm looking for is engine 7.5 and ignition 7.5A. So ignition, see, I have different amp ratings. So I have engine 7.5 charging system and then ignition 7.5, but that's 10. And I can see engine 7.5, the description is this charging circuit, and then the ignition discharge warning light, which is the warning light that came up that looks like a battery. Okay, so number 8. So that's the dead middle. On these blade style fuses, you can look through the little observation glass area and there will be a metal piece that's supposed to be continuous. If it's blown, then you have a faulty fuse. A visual inspection is usually enough. We can see that it's not blown. Sometimes it'll be really dramatic and smoky and look like there was a legitimate explosion inside there. However, if we want to be 100% sure that this fuse is okay, then we need to measure continuity. And continuity is simply a test to see if a circuit is continuous. So if a wire or circuit is continuous, then it will react. So on most multimeters, the best way to do it is go here to the ohm symbol, the omega symbol, and we will be measuring resistance. Normally resistance can be measured, how much resistance is in a circuit, as in how much resistance to electrical flow there is. We can test continuity with almost anything. For example, this wrench is metal and conducts electricity. So because this has continuity and it is one continuous piece of metal, and it is metal so it does conduct electricity, we should be able to measure the resistance as well as see if this thing has continuity. And our meter moved, which indicates that it is in fact continuous. So if we take it off, it'll say OL, which is overload, but we can now measure the resistance of our little wrench. Although we have to be careful because we are on wood, which does technically conduct electricity. Now we do the same for our little fuse. I'm going to attach my ground lead and then my test lead. We are going to see, and we get movement, my OL goes away, and we have a resistance measurement. So that fuse is in fact continuous. And that's that. Next in our fuse box, we have these guys. I don't know if these are technically fuses or not. These bottom two, 120A and 30A, well, 120 amp and 30 amp, alternator and AM2 are here. Now these are a little different because underneath this panel, and be careful not to break it because mine already is, but underneath this panel we have these bolted on pieces of wire. So you'll have to undo those bolts to actually remove these. Inside these sight glasses, you can see there is a piece of metal, and we are looking for that same kind of continuity. If this looks blown up or disconnected or broken, then you have a bad fuse and you might need to replace either one of these. Because it is a pain in the butt to remove these, it's a lot of work just to test them, so I'm probably not really going to do it, although visibly it looks like they are fine. So those are things that you need to check before we buy and replace an alternator. There's another common thing that happens on these cars that is really worth talking about, and that is the fact that the power steering pump and reservoir are directly above the alternator on these cars. There's also two lines that head out from the pump. These lines and the pump itself are really susceptible to leaking, and they will leak onto your alternator and cause a mess of problems. So it's very common that people create a little shield to go over the alternator that helps protect it from having the fluid dripped onto it and kill it. So I would say on the Lexus LS400, before you replace the alternator, you should have a really good look around your power steering pump and system to see if it is pouring fluid onto your alternator. Otherwise, you'll replace your alternator and it will die again. Step number one in removing the alternator, I am going to undo both the negative and positive terminal. Start with the negative always, and installation is the reversal. Take the negative off, then the positive. This way we won't have any electrical current going anywhere, and we'll be good to remove the alternator. Next, we will lift the car and place it on jack stands. Always use jack stands. I'll lift it using the subframe. Honestly, I'm going to back up a little bit. Alright, so looking below here, we have this pulley here, which is our auto tensioner. And this is how we will undo our belt. So it's right here to the left of the crank pulley. I will use just a regular wrench to get on the bolt. I will go counterclockwise, which will pivot the tensioner out of the way, which will allow me to slip the drive belt off, potentially. Since I'm only replacing one component and trying to be rather efficient here, I am only going to take the belt off of one component to try and make my life easier. So when I reinstall the belt, all I have to do is just kind of put it back on instead of messing with the whole thing. So I took it off this tensioner here, and that will give us enough tension to release it from the alternator. Right, this plastic piece is being held in by 3 10mm, and it would just be nice if we had some extra room. I think we need the room to get the alternator out, so that's first. Alright, so you kind of have two options here as far as the two wires. We have the battery positive, which is the big voltage, and then in the back of the alternator we have the plug that operates like the control of the alternator. Now you can unbolt the alternator and then undo those plugs before or after. Ultimately it's going to be up to you. It might be easier to access the plugs once it's out. I do have a replacement harness pigtail that I highly suggest, because it becomes very hot, very brittle, and that other guy tends to fail, and I believe that's what happened here. I think I'm going to try and get this battery positive off first. I know it in fact has a 13, which I will now remove. It was actually a 12mm, because why would I ever be right in the first place? So you can see the top bolt way up there. And then we have our socket on the bottom bolt here between these two power steering lines. And those are the two that we will undo. They're accessible from the front like so. Alright, once you release that bolt, this bracket will become loose, and it might bind up with the alternator a little bit, so keep that in mind, and just, you'll have to move this bracket a little bit to get the alternator out, but with those two bolts we should be free to go. Through the wheel well area is going to be kind of the easiest way to get this out. I mean, ultimately you'll just kind of, actually, am I still stuck on something here? You will need to go forward a little bit to come off of a stud before you pull it out. And then keep in mind, if you haven't undone your wires, be careful when pulling this out. And I think, you know, you can really damage the wires by doing this. I think last time, I think I positioned it forward like this. And I was able to slide out, but unfortunately you can see our constraints here. You are going to have to wiggle it around a little bit to pull it out. I want to show you what my connector looks like. So this is what I believe is the cause of my issues here. As you can see, it is destroyed. Last time replacing this, yeah, it was rough. These get really brittle. Obviously, I destroyed it. I should have replaced it, but I didn't. So I can almost guarantee that's where my issue is coming from. I'm a little tempted to just replace the harness and plug it back in and see what happens, but it is quite a bit of work to do so. So I'll have to think about it for a second. All right, now that we're dangling, I can get this off. I am taking a video to note the alignment of the wires. So we have yellow, black, whatever, and those will need to be in the same order according to the plug, and our tab was here. I'm going to go ahead and snip it now, since I don't want to deal with that. So the plug also became very corroded, so I think that has been causing a lot of electrical issues. But those terminals are going to be pretty fucked too. But I bet this alternator is fine. So it's pretty reasonable to think this chewed up thing is our problem. The other silly thing is we have this shield that needs to be transferred over. So little 8mm bolts. There's also risers, which we need to transfer over. I'm going to start by trimming some of the extra wire from the pigtail that we just know we're not going to need. So we have a very short distance here. Generally speaking, it's good to stagger them. And then we'll go ahead and... that was too much, god damn it. Give it a little bit of a twist there. And crimp. Got a nice tug. That ain't going anywhere. Same thing again. Strip the wire with my wire strippers. Put that bad boy over and crimp it. Hopefully it'll come with these nice butt connectors, these butt terminals. These simply help splice wires together. They also have heat shrink tubing at the end, which will allow us to insulate it for a nice weatherproof seal, so we don't have to do this again. So all I'm going to do is I'm going to use the appropriate size wire stripper, strip back that wire, give it a light twist, and then insert it into the butt connector. These butt connectors should be the right size. And then with the other end on our tool, depending on which type of tool you have, you will have a crimper in which you crimp the butt connector close. And then we have a nice, strong connection. Underneath the car, we have the same thing going on. And we want to strip back the wire. Now careful, because these are actually thinner and potentially more delicate. So these are, in fact, a thinner gauge, which is interesting. This one's large, very large, in fact. And we will strip all of those back. We want to be very careful because we do not want to take a single strand of wiring out. Alright, now I will check my diagram. A really helpful tip here is if you grab the butt connector in your tool like this, it's a lot easier to control. And then just make sure that's nice and wound up, and then you can feed it in like that. Uh-oh, that's what I was a little worried about. So when you run a lighter or a heat gun over these, they insulate, which is amazing. You can see it's kind of bulged out. When you run a lighter over that, it will shrink and insulate your connection. So these are a great way to do some wire repairs on most cars. Harness is all repaired, wrapped up, and clean. So now I just have to decide if I want to tighten the B+ post and install the harness before I install the alternator, or what. I think I'm gonna get it in place first. And then we can tighten it. Alright, we're tightening it all back up. We just have the 2 bolts. You got to kind of figure out how you're going to maneuver the alternator into place, but it's just the reversal. I did end up getting it kind of in place. I plugged it in, and then I tightened the battery positive terminal, and now I'm just tightening the bolts. I am just going to hand tighten them with my ratchet, and I'm going to crank them on pretty good. I'm not going to torque them, but that should be all right. And the harness is kind of there. I mean, I'll probably get a zip tie or something to manage this a little better, but nothing too special there. Also, as all of this goes back together, make sure, you know, we have like serpentine belt. We do have our wiring harnesses and all this other stuff. Make sure that nothing's getting pinched. Nothing is in the way of anything else. And just be very mindful when you're tightening. Make sure that you don't have like an air gap between the mounting surfaces. We don't want to forget about our power steering line, as well as our splash shield that we took off, and anything else that we might have unbolted to help us out today. Once the alternator is all done on the bottom, we can put the car on the ground, get the belt back on, and then we can put our battery terminals back on, which is what I'm doing now. And then I'm going to start the car and see what happens. Uh-oh. Well, my key was on. That's really not good. Alright, we got our test lead and our multimeter. Alternator's working again. I started the car up. Everything seems fine. The voltage is at 14.4 volts while it's running, which is what we want. So the second thing that's really important to understand about this job is I actually have done my alternator twice in the past couple of years. The first time, I just went in and I replaced just the alternator, which is why I didn't do the LS430 upgrade, because I just wanted to swap it out and solve my problem, and that was a case where the alternator just failed and wasn't charging my battery. Over the next year, I was having a very annoying, persistent problem with my electrical system. Basically, it seemed like the voltage was oscillating. My lights, the idle, and everything about my car would go ooh. It was very, very annoying. Additionally, at the time, I also developed a random intermittent misfire. So I thought I had some random electrical demon. Also, keep in mind this happened shortly after I just pulled off the intake manifold and all of these components, and I just replaced the starter motor. So I was really worried that I had made some kind of mistake, or I damaged a sensor, or something happened to the point where I messed something up, and now I have these really weird issues. It turns out the misfire and the oscillating idle were different issues, and the oscillating idle, I'm not kidding, it actually came to me in a dream. I had a dream that underneath my car near my alternator there was a wire hanging. That isn't exactly what happened, but I looked at the alternator and I got a good look at the back of it, and I could clearly see that the connector was, well, super damaged, as you saw in the video. Because of that, moisture and whatever got in there, and the whole plug as well as the terminals on the alternator itself were corroded and definitely causing my issue. Now, because I replaced the connector and the alternator that time, that would have been a great time to do the LS430, but I did want to just throw out there that, you know, if you do this job and you damage the connector, which is extraordinarily likely, definitely replace it. Otherwise, you'll be like me and you'll spend a year chasing some electrical demon when it was something really obvious that you messed up recently. It's also worth noting that, again, I tried avoiding replacing the connector and just being gentle, and it was just too brittle. It was just too old and brittle. So I might even suggest that you order an alternator connector before doing this job, just to have it. Just because it's likely that it's going to get damaged. And with that being said, given that it's so likely that that connector might break, I would really seriously look at the LS430 upgrade. Regardless, I wanted to share that and be kind of transparent. I'm going to talk about hunting down that idle issue a little bit, because it was really annoying and really kind of silly. But don't forget about mess ups that you had in the past, and do things right the first time. Again, I tried to do it as quickly and cheaply as possible. Didn't want to have to mess with rewiring that harness. As you saw in this video, really wasn't that hard at all, and it's something I could have just done, but instead I just had a year of stress about some weird random issue. Thanks so much for watching. I hope this helps some people replace their alternator or maybe troubleshoot some weird issues that they're having. Thank you so much for watching. I'll see you later. Keep wrenching.